Namaste. Welcome to PABSON Distant Learning Education Program with Janata Television. And today in grade 10 science, we are going to discuss about pressure. Okay, so about the pressure, definition of pressure you might have learned in lower class also. So first let's see what is pressure. And before defining this pressure, what we are going to learn on this pressure is about the liquid pressure we will discuss here, and similarly about the Pascals law and its application we will discuss here, and similarly we will discuss the Archimedes principle and its applications we will discuss here. Similarly, law of flotation we will discuss here. So these things we will discuss on this grade 10 pressure topic. Okay, so let's see what is pressure. So whenever I apply the force, so definition of pressures I'm going to define. So whenever I apply the force on some certain area, then the force exerted on some certain area is defined as the pressure. So pressure is the force per unit area, and the unit of pressure it is Newton per meter square, and combinedly we call it Pascal also. So unit is Newton per meter square, or Pascal is the unit for the pressure. So now let's see what is liquid pressure. So the pressure which is exerted by the liquid per unit area is called the liquid pressure. That means whenever we put the liquid on some vessel, then some certain pressure is exerted on the vessel, on the bottom of the vessel, which is known as the liquid pressure. And the unit of this liquid pressure also same as the pressure, that is Newton per meter square, or Pascal is the SI unit for the liquid pressure also. And for liquid pressure, for calculating the liquid pressure, the modified formula is there. So this pressure formula P equals to force per unit area, and for the liquid pressure the new formula should be derived one. So we will write down this P equals to dZh, and this one can be written as a rho z h also. So dZh or the rho gh is the formula for calculating the liquid pressure. And why this formula is modified one is the liquid, it contains the area of the vessel. If the area of the vessel vary, then the area of the liquid also get varied one. That's why the modifications of formula is there. So this derivations of this formula you might have learned in grade 8 also, but also, so let's see how to derive this one. So for this one we will take one vessel, right, and we will fill the liquid on this vessel. So this is liquid, or we can say water also. Let's say this height of the liquid column is h, and the cross sectional area is a, let's say, and the density of this liquid is d, or rho we can write down the density of the liquid. So from the formula of pressure, P equals to force per unit area, and in this case, in this liquid, in the case of this liquid, the force exerted by this liquid is equivalent with the weight. The weight of this liquid is equivalent with the force. That's why we can write down from here this m into z by a. Okay, and this mass, so in this case, so here is the mass, it is difficult to calculate. That's why instead of mass we can write down, so we have density equals to mass by volume, right? So we need this mass, mean we can multiply this m equals to density into volume, right? So instead of this mass, let's put the value rho and v, rho v into z by a, right? So volume, so here instead of this volume we can write down in terms of area and the height also. That means this density as it is, instead of this volume, volume is area into height, right, into acceleration due to gravity g as it is, divide by a. So this area, this both is similar one, so we can cancel. Therefore liquid pressure P equals to rho z and h, where rho, it is the density of liquid, g, it's an acceleration due to gravity which is constant for the particular place. The average value is 9.8 meter per second square, and this h is the height of liquid column. So this is the formula for calculating the liquid pressure. Now this liquid pressure P equals to rho g h, mean density of liquid, it's a constant. For the certain liquid, the density of liquid is constant, and acceleration due to gravity also for the particular place, it is constant one. That means this density and the acceleration due to gravity is constant. That's why we can write down this P is vary with the height. That means liquid pressure is directly proportional with the height of liquid column. Why? Because density of liquid is constant and the acceleration due to gravity is constant. So the liquid pressure, it vary with the height of liquid column. Okay, so you can see in the screen there is one demonstration that how we can prove that the liquid pressure vary from height, or the vary according to the depth of liquid column. So you can see there one tank, right, and there is a 3 sprouts are present over there, and the lowermost sprout, you can see there in the lowermost sprout the liquid flow with the greater force. That's why it will just emerge up to the more distance. Why? Because the height of liquid column is more, right? In the topmost part the pressure is less because the height is minimum over there. The liquid height is minimum, so the pressure is less over there, and in the bottom part the liquid pressure is more due to the more liquid height or liquid column. That's why the liquid pressure, it is directly proportional with the height of liquid column. That's why whenever you collect the water in the bucket in your house, then in the downstairs the water will fill fast in comparison to the upstairs. So about this, the different give reasons you might have learned in grade 8 also. So remember only the height of this liquid pressure, it is directly proportional with the height of liquid column. So this is about the liquid pressure. Now let's move on to the next topic, that is called Pascal's law. So what is this Pascal's law? Let's see. Okay, next one is Pascal's law. So this Pascal's law, it is derived, or it is propounded by the person called the Blaise Pascal, and he formulated this on 1647 AD. This is the Pascal's law, right? And this Pascal's law, it is also called the principle of hydrostatics also. Hydrostatics, it is a branch of science which deals about the fluid. Fluid means that matter which take the shape of the object or shape of the vessel. That is called this that is called fluid, and the branch of science which deals about the fluid, the properties of the fluid, is called the hydrostatic. So this Pascal's law, it is also known as the principle of hydrostatics. So I have one vessel. So what is Pascal's law? I'm going to define. Okay. So this vessel, it is a closed one, right? It is a closed vessel. So whenever I feel the liquid on this closed vessel, okay, let's say I will feel the liquid on this closed vessel. So if I apply the pressure, okay, if I apply the pressure on this liquid enclosed in the vessel, okay, once again listen. So I have the one vessel, closed vessel is there, and if I feel the liquid here, this is in the closed vessel, so I will feel the liquid in this closed vessel. So if I apply the pressure on this liquid enclosed in the vessel, then the pressure will transmit equally in all the direction perpendicularly. So this demonstrations you can do in your home also. So take a vessel, plastic bottle, and you make a number of hole over there, right, and fill the water inside it. So whenever you apply the pressure on this vessel, then you can see that the equal amount of water right, up to the certain height that will emerge from this vessel whenever we apply the pressure. That is the statement of this Pascal's law. So, once again I will repeat this statement. So, when the pressure is applied on the liquid, okay, we will apply the pressure on the liquid enclosed in the vessel, then the pressure will transmit equally in the all the direction perpendicularly. This is the Pascal's law. Okay, that is the statement 1. So, let us remember the statement. So, we can experimentally verify this Pascal's law also. Okay. So, for this, so I will take this one closed vessel. So, let us say this is the closed vessels where there contain the 4 piston. Okay. So, 4 pistons are present over there. So, 1 piston, 2 piston, 3 piston and the 4 piston, right. It is the enclosed vessels. So, I have filled the liquid here inside it. So, let us say water is filled here, right, water is filled, and here is the 4 piston I have said. So, this is the 1 piston, right, and this one is the 2nd piston, and this is the 3rd piston, and this is the 4th piston. So, let us say this is piston A, this is piston B, this is piston C, and this is piston D. And if the area, okay, this piston, if it has the equal area, right, then if I apply the certain force on this piston A, then the certain pressure is exerted on it. Whenever I apply the certain force on this piston A, then the certain pressure is applied on it, and the result, whenever we apply the some force on this piston A, then whatever amount of inward distance is there of this piston A, that means whatever amount of distance is traveled by this piston A, the same amount of outward distance will be there of this B also, of this C also, and of this D also. That means, suppose if there is a certain length is traveled inward when I apply the some certain force, then this B, C and D, they will also move outward by the same distance, which prove the Pascal's law. So, the Pascal's law is whenever we apply the pressure on the liquid enclosed in the vessel, then it transmit equally in the all the direction. Okay, that's why this is the experimental demonstrations of the Pascal's law. So, with the help of this experiment, we can prove this Pascal's law. Okay, and this Pascal's law, there is a lots of applications are there in our day-to-day life. For example, we can use this in the hydraulic press also, right. Hydraulic press, you might have seen that the cotton get compressed. Okay, whenever we apply the less amount of force, then this hydraulic press, it create the more amount of force, and it is specially used for compressing the cotton, and in the press also it is used one. Okay, so this hydraulic press also the applications of this Pascal's law. Similarly, the hydraulic brake, we can see the different the heavy vehicles in our surrounding one, in which the hydraulic brakes are used one, right. That is also the applications of this hydraulic machine or this Pascal's law. Okay, and similarly the hydraulic garage lift also, you might have seen whenever we take the car for washing, then the person can lift up the car, that is by using this hydraulic garage lift. That is also the applications of this Pascal's law. Similarly, the hydraulic crane and this hydraulic lift, it is also called the elevator also, and the hydraulic jack, they are the some instrument or device which are based on the Pascal's law. That is the applications of Pascal's law in our day-to-day life. Now, let us see what is this principle of hydraulic machine. Okay. This hydraulic machine, it is the device. Okay, hydraulic machine, it is a device which are based on the Pascal's law, and which are used to multiply the less amount of force into the more amount of force. That means the more force get produced by applying the less amount of force by using this hydraulic machine. Okay. Okay. So, let us see this the principle of this hydraulic machine. So, for this hydraulic machine, it consists of 2 cylinders of the different diameter. One is of small diameter and next one is of the larger diameter one or bigger diameter one. So these two cylinders are connected by the tube called T, let's say. Okay, so the fluid is filled inside it, the liquid or water is filled inside it. So let's fill the water. This water is filled on it, right? And there consists of two pistons. Two pistons are there. So let's say this one is the piston 1, right? And this one is piston 2. Let's say this one is the piston, second piston. So this one is first piston and that one is the second piston. Let's say this force applied on this first piston is F1, okay, and the cross-sectional area of this piston is A. The force applied on this first piston is F1 and the cross-sectional area is A. Similarly, the cross-sectional area of this piston is, let's say, A2. So this one let's represent by A1. This one is A2 and the force created on this is F2. So let's say here is a F2 force is created here. Okay, so this is the constructions of this the hydraulic machine. It consists of two cylinders of different diameter, right? And the pistons are, two pistons are placed, that piston 1 and the piston 2 is there, okay, and the liquid are placed inside it. So the pressure exerted on the first piston, so here the pressure exerted in first piston. So if I represent this by P1, then P1 equals to F1 by A1. Can I write down this equation 1? Right? Similarly, this further in the next cylinder, they exert the pressure over there, right? So the pressure exerted in second piston. So if I represent by P2, then P2 equals to F2 by A2. So this is equation 2nd. And the Pascal's law says that the pressure exerted on the first piston, that is equal to the pressure exerted on the second piston. So from Pascal's law, so what we can write down is P1 equals to P2, right? So if the P1 and P2 are equal, let's put the value of this P1 and P2. This is F1 by A1 equals to, this is F2 by A2. So one more step here. This one is F2 by F1 equals to A2 by A1. So what this means is, if the cross-sectional area of second piston, let's say A2 is very much greater than A1. What I mean is, if the cross-sectional area of this piston make very large than the piston A, this first piston, then the force created on there will be also very much greater than the force created on the first one. That means whatever we apply the less amount of force here, if the more cross-sectional area is made here, then the force created on this piston also will be comparatively more enough. That's why this hydraulic machine is considered as a force multiplier. Why? Because the amount of force created on the second piston is comparatively large by making the large cross-sectional area. That's why this hydraulic machine is called the force multiplier. Okay, so it is called this force multiplier. Now, this is the principle of this hydraulic machine. So let's see the hydraulic garage lift. Okay. So next one, we are going to talk about the hydraulic garage lift, how this hydraulic garage lift works. So you might have seen, I have already said, the car can be lifted by a person by using this hydraulic garage lift. So how it works, this hydraulic garage lift? So let's see. So there consists of 3 cylinders of the different diameter. Okay, so let me construct this. So this one is the small cylinder, right, and next one is comparatively large cylinder are present here. Okay, this is the figure for this hydraulic garage lift. Okay, and there consists of 2 valves. So one valve is present here. Okay, one valve is present here. So this is the one-way valve. Okay, this is one-way valve, and next valve is present here. This one is next valve. Okay, and this cylinder, it is called the reservoir, and this one is the large piston, right, and this one is the small piston. So I will put here the piston. It's of a larger cylinder one, right, where the load can be lifted up, and this is the small piston, right, where we apply the force, less amount of force we apply here, and this one is called the reservoir. Okay, and this reservoir and the large cylinder are connected with the small tube. Let's say this one. So it is connected with the stopper. Okay, so this one is called the stopper. Let's say it is the stopper T. Okay, so this one is stopper T. So you can practice this figure yourself also, this one. Okay, and here the liquid is filled one, right, liquid is filled. So this one is liquid, this is liquid, this one also liquid. Okay, you can see this in the screen also. There I have kept the figure also, right. So this one is the hydraulic garage lift. Okay, so you can put here the some vehicle. So let's say this one is vehicle, right, this one is vehicle. Okay, let's say this one is vehicle. Okay, and here consists of this lever also, it consists. Okay, lever mean we apply the force here with the help of lever. Okay, this is the structure of this hydraulic garage lift, right. So how it works, let's say, so this I will represent this valve A, this one is valve A, and this one is valve B, this is valve B. So this I have said it is the stopper one. So this is construction of this hydraulic garage lift. Okay, so how it works, let's say, so this one is, here is also contained the liquid, and this one is stopper. Okay, so let's see the working of this hydraulic garage lift, right. Okay, this is the larger piston, right, where the load can be lifted up, right. This is the small piston where we apply the force. Okay, and similarly this one is called the reservoir, so collections for the liquid, right. So how it works, let's see. So when we apply the force, okay, when we apply the force on this piston, right, in the lever, especially in the lever, then certain amount of force is exerted on it. So can I write down this P1? So what I have said is, when certain amount of force, okay, certain amount of force is exerted on this piston, then certain amount of pressure is exerted on it. So I have represented this by P1. Okay, then according to the Pascal's law, the same amount of pressure is transmitted in all the direction perpendicularly and equally. That means whatever pressure is applied on it, then the same amount of pressure is transmitted to all the direction perpendicularly and the equally. Mean in this direction also the pressure is exerted one, in this direction also same amount of pressure is exerted one, and in this direction also same amount of pressure is exerted one, right. That means this is one way valve, mean the liquid cannot pass on here. Why? Because this is get closed one, right? This is one way valve I have said. The pressure exerted on this valve get closed the valve, right? And this also there is no any place to transmit the pressure, but here the pressure get transmit through this valve B, and that pressure will exerted on this one, right? On the larger cylinder the pressure is exerted one, and this pressure cause the certain amount of force on this piston, and the vehicle is lifted up, right? That means whenever we apply the force continuously here, then this vehicle is get continuously lifted up by the applications of this Pascal's law. And after this lifting on the certain height, whenever we need to reset this, whenever we need to get back this vehicle on the same level of ground, then for that this stopper is useful one, right? So whenever we open this stopper, then the liquid from this chamber, this larger cylinder, get transmitted to this the reservoir one. And similarly, when this liquid, when we lifted up this piston in the upward direction, in that condition the pressure, this liquid pressure or the pressure get decrease here, some space is created over there, this space is filled with the liquid from this chamber. What I mean is, when we lifted this lever in the upward direction, this valve B get closed. It's a one way, right? It get closed one, then some vacuum is created over there, this vacuum is filled from the liquid from this reservoir to the liquid is transmitted to this the small chamber. So in this way this hydraulic garage lift work, and especially this is used for the maintenance of a vehicles, right? And for the over there you might have seen that cleaning of car, right? This car service center, there this hydraulic garage lift are used one. So this is also the applications of the Pascal's law in our day-to-day life. And next one, hydraulic brake is there. Okay, hydraulic brake is there. So you can draw the figure along with me for this hydraulic brake also. Okay, so let's try to draw the figure of this hydraulic brake. You can continue with me. So this one, right, and it is connected with the cylinder. Okay, the two cylinders are present over there. So this one, this is piston, right? This one also piston, and from here it is connected with the next one piston. So this is next piston. Okay, you can feel the fluid here, right? And here is presence of this pedal. Okay, this pedal is present over there, and this rim is connected with the brake shoe. You might have heard about the brake shoe. It is made with the rough surface, right? And this brake shoe, it is connected with the inner rim of the wheel. Okay, this one is the inner rim of a wheel. So this is inner rim. So let's label this one. So this one is inner rim of wheel. Okay, and this one is called slave cylinder, right? This one is called slave cylinder. So this one is called, it is called the slave cylinder, right? And this one is called the master cylinder. This is called the master cylinder. So this liquid is filled here. Okay, the liquid is filled here. So this one is called the brake shoe, right? So this is brake shoe, this one is called slave cylinder, and this is inner rim of the wheel, and this one is master cylinder, and this portion you have seen, it is called the pedal, where the brake is applied one, right? Okay, so how it works, let's see. I will explain in short. Okay, so this whenever we apply the force on this pedal, right, we apply the force in this pedal, then the force applied on the pedal cause the pressure exerted on this master cylinder. Okay, and from this master cylinder the pressure will equally distribute to this slave cylinder, and this slave cylinder cause the force on this portion, right, which cause the brake shoe push towards the inner rim, which slow down the velocity and come completely on the rest. Okay, so by applying this we can stop the very heavy vehicle also. So today we have learned about this Pascal's law and some applications of this Pascal's law. So next time we continue the remaining portion. So thank you very much for joining the class. Thank you very much.